section. We're continuing on in 6-4. And we should be able to get through all of this today. We did last hour, so I'm not really concerned if you guys are going to get through as well. This is still 6-4. What I want to do here real quick is get your brains back in the whole factoring mode, because we use some of these things later today. Yeah, we just add to it tonight. Not a big deal. You see an equal sign? Flame! Flame squad. This is just plain old boring factor, so take a minute. Dylan, what is your very, 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 very first rule of factoring? GCF. GCF. Go common factor. Go common factor. Go. Go common factor. Go. Sorry. Anywho, what is your GCF in the first one? 4x. 4x. So you factor out a 4x, and you're done. Okay. Now the other style is where we do the factor by grouping. Okay. Where you're going to split out that middle term. So what's 2 times negative 21?
Negative 42.
What times what is negative 42? When you add it together, you get positive 11. What's that? Excellent. 14 and negative 3. So now, when we go to factor by grouping, we're basically taking a trinomial and putting it into 4 terms. Okay? When you had alternating signs, do you guys remember what my trick was for less likelihood of screwing up? Put the negative first. No, it's just you'll be less likely to screw it up.
Wait, is that
If you,
times
14 times negative 3. Oh, sorry, minus. And now we factor it by grouping. Whenever you see 4 terms, you're usually factoring by grouping. Take your GCFs. And what's the GCF of 14 and 21?
7.
Are the 2 things that are written within parentheses the same?
Yeah.
Right.
No, it's 3. I honestly love this.
Okay. Well, that's the same kind of stuff that we're going to work on today, but with higher order degree polynomials. So we're just going to work with higher degree polynomials. So you have x cubed minus 2x squared minus 9x plus 18. Our degree just went up. It's getting hot in here. Awesome. So now, one of the things that happens when you're factoring, the first thing you always look for is there a GCF? Okay. After you see whether or not you have GCFs, then you start using all the other methods that you remembered how to factor. Factor somehow.
Real specific. Nice.
Factor. Now, hint-wise as far as factoring is concerned, if you have 4 terms, you're probably grouping. If it's 2 terms, think difference of squares, difference of sums or difference of cubes. And if it's 3 terms, think trinomial. Now when I'm saying think trinomial, that's when we did what times what is something that adds to the middle term. That kind of thing. All right? So do those generic rules always work?
No.
No. It's just kind of a rough idea of what I would be looking for. Okay? Bless you. So in this one, I have a 3rd degree polynomial. I have 4 terms. What do you think it's leading you to try and do? Group them. So let's group them. Group the first two and the last two.
Well,
Now, what would I do with my third term that it's negative so I don't screw it up later?
put it first.
I do that. I do the same change opposite in there. Okay? So now I do my GCFs again. Take out the x squared, and I'm left with x minus 2. I put that first term to be a -9, so that means I want to make sure I remember to take the negative out. So I factor out a -9, what am I left with?
X minus 2.
Are the two things that are in parentheses the same?
Yes.
Write it down. And what are you left with?
X squared. X squared.
So are you done?
Yeah.
No. Difference of squares. Wait.
Difference of squares.
That's what I was going to say.
Nice. So X minus. I was just
Will it always look out like so? There's
Not necessarily.
3.
Now-
Crazy.
You wind up with the difference of squares there at the x squared minus 9. So when you get these higher order degree polynomials, you're still doing the same basic process, but as you're lowering your degrees for your terms, you still got to look within those terms in case they're still factorable. In this case, x squared minus 9 is factorable because x squared is perfect square, 9 is a perfect square, and it's a subtraction symbol. So you have to pay attention to those little nuances that show up from time to time. Now, if it was x squared plus 9, would you be done?
Yes.
Yes. So now think about this. What would change? You'd solve, right?
X equals 2. X equals 3.
Now for 1 billion points, what direction is this graph going?
Up.
It's going like this.
Yeah.
Okay, so I was right.
I didn't ask you. You got to make it because it's more cool. It's cooler. It's an odd degree with the first term that's positive. Okay?
You get a million points now.
It was actually 1 billion points, but since you forgot that, no. So take a second and do these two.
Interesting.
That's crazy.
Look at this first one. On the first one, I'm guessing most of you guys recognize that the first one's a perfect square. The second one is a perfect square, and it is a
Difference.
difference. Difference of switches? It's either on or off?
Yes.
So 9x
9x squared minus 4,
times
9x squared plus 4. Hopefully you didn't stop there, because what is 9x squared minus 4? It's a difference of squares.
That's minus 2.
Yay!
And now you're done. Yes.
So
We took out.
we got 3x minus 2 like in the first place, and then we did like 9x squared plus 6x. Still really loud.
Okay, now I have no idea how to do
9x squared plus 6x plus
Because
what?
those are perfect quadrilaterals. Whatever it is when it's to the power of 4. Because 81 is 3 to the power of 4, and 16 is 2 to the power of 4. And so we took that out, and then we ended up with something different.
Okay, so you wrote it as
3x minus 2 times 9x squared plus 6x plus 4.
there's nothing there you can factor out. You're right, they're perfect fourths, but there's nothing there you can factor out to do that. Okay. What you were thinking of, in essence, what you were doing would work for solving for real solutions if that equaled 0. Okay. In essence, that would work in that route, but it doesn't this way. Okay. All right. So this would be your solution here. Now the other one takes a little bit of getting used to of seeing here. Does everybody agree that you have to do GCF first?
Yes.
So we're taking care of the GCF.
4x squared.
4x squared. Now, if I take out the 4x squared, I'm left with x to the 4th minus 5x squared plus 6. Now, does that 4x squared go away, or does it have to stay?
Yes, it is.
Why?
Because there's just not equal to 0.
Excellent, because it doesn't equal 0. So now, treat this like you would a regular old trinomial. And the reason why you want to treat it like as a regular trinomial, look at your degrees. 4, 2, nothing. Either going down by half each time, okay? So what you're looking at here is what times what is 6 you add together to get 5. So it's x squared minus 3, x squared minus 2, and we have a 4x squared out front. Can I factor any of those any further? No. Because I have differences, but I don't have perfect squares though. Okay. And I'm done.
So it works the same even though that's the
Yeah.
exponents are different?
Yes, sir.
Is that just in this case because 4 and 2 are
Yes.
equal to 2?
It's only going to work when they're even going down like that. You know, 8, 4,
But
and
what if they're
nothing.
not?
Same idea.
We're even talking.
You'll see it right away. It's blatantly obvious when it's going out like that.
If someone's like, say, oh wait, never mind.
Okay.
Because 6 squared would just be a 0, would just be 36.
Come on.
Isn't x squared minus 3 minus 2 squares?
Is 2 a perfect square? Is 3 a perfect square? You're thinking ahead of yourselves by trying to find zeros. We're not worrying about that.
Okay.
Speaking of zeros, oh no, what do I do now? Subtract it? Okay. And we said it equals 0, yeah. Yeah, go ahead and try and solve for your zeros now. I haven't done that really all the way through yet. Let's see if you guys can figure it out on your own.
Wow. Okay, it's recording.
We'll let them finish before we make fun of them.
I already know they're going to be wrong.
I mean, he wasn't trying to be nice.
Read the short.
Do some comment and keep writing. Only I can heckle. Ooh.
That was a cow, wasn't a cat.
It was a cow. Yeah.
What is
Ooh.
that?
Ouch! Seriously, put me down.
That's why you should keep them down.
You guys like shut up, please.
She said please. That was nice. Shut up, please.
Cayete, abuela. Fire in Spanish 3.
Yeah, no, you're playing. Grandma's going to abuela. Is that grandma?
Yeah, she writes like your grandma. Why would you write like
Oh! No, you don't.
No, Bajo was right. You played it in Spanish.
Who would have thought that Algebra 2 would have so much Espanol in it? ¿Dónde están dos X? X.
It goes away because it's equal to 0.
No! Mi corazón.
There's a variable.
There's a variable there.
I told you got it wrong.
This is what happens is since there's the variable, it doesn't go away. If it was just a constant. Yeah. Hey guys, this is a very common mistake. It's a very common mistake. We're so accustomed to anytime we took that GCF out, if we would have said equal to 0, we would just get rid of it. We don't get rid of it in this case because there's still a variable tacked on to it. All right, that's all.
We did it wrong.
Oh, look who called it.
It was me. Who did it wrong? Julia did it wrong. Julia told me.
Does that make sense why you can't get rid of that variable there?
Yeah.
It's-
And there's like
Yeah. What you did here what you guys did here by setting them everything equal to 0 right off the bat and not factoring in that last step, that's perfectly fine. It's perfectly fine when you get to this point to solve for your zeros because it's asking you to solve for zeros. If it said factor completely, you would have to go that extra step to factor, plus x plus 2x minus 2.
Oh, so we're right.
Yeah, you're fine. Yeah.
Who did it right?
You didn't have to do this x squared minus 4. So either way, you're going to get plus or minus 2.
Correct. And once again, guys, I need you to listen to this carefully here. The fact that this was a solve for your zeros problem, that meant all you do is get your zeros. You did not have to factor it fully in order to get there. That's why just leaving it as x squared minus 4 is okay. Because you're going to set that term equal to 0 and get your plus or minus 2 for it. Now, if it said factor completely, you'd have to write x plus 2x minus 2. Yes, sir?
Why can't we get rid of that 2x?
Because it has a variable.
But wouldn't it technically be, if you get rid of that, wouldn't it be 0 anyway? So it would just make the...
No, because then when you get rid of it, you don't have 0 as an x.
Correct. If you get rid of it, if you get rid of that value of this, then you're telling me that 0 is not a possible 0 of the function. What's happening here is that you've got 5 possible x-intercepts here because this is a 5th degree polynomial, which means you should have up to 5 possible real solutions. Our real solutions are 0, plus or minus root 3, and plus or minus 2. So this is doing your zigzag, zigzag going on up, okay? So whenever you have a variable out there, you just leave it, okay? Good work, girls. Let's do another one.
Can I do that one?
I don't know. Let's see how we go. It was easier for you to reach that than it was somebody else, wasn't it?
They do hear that on recording. I'm like, they're not even going to hear that one.
I'm sorry.
No one even watches the recording.
I watched it one. I watched the.
I watched it one time.
that one day. I was like, I did it. Every time I watch it, it's always like a weird remark. I'll do my mom watch
Help me on the date that you
No, I only watch it. I watch it when I want to come
Yeah, it's always weird. I had in conferences one time after I first started doing this, a parent was walking by their kid's room and they heard a man's voice and it was loud because they had it turned up on the computer. They're like, who's in there? They look in there and they're like, Dewey, who are you talking to? They're like, nothing. I missed class today because of such and such and I'm just watching my math lesson. You're doing what? Yeah, Mr. Murphy does this in class. And she's like, the parents were like, that's really cool.
I was watching one and my brother comes home and I had no idea what it was.
Are we going to have a test next week?
Tyler can't wait to be out.
Tyler's gonna be like the 5th grade algebra for the next CCC.
Yeah, I didn't understand it.
Yeah, you were,
You're gonna be in like algebra 2 freshman. She's gonna be in
no,
like
6th grade, just the 6th grade.
Number 8.
Alright, let's see what we got here. Let's critique. You know what? You're the second person to do that grouping like that. I have never seen anybody up until today switch flip-flop those two little values. Who taught you that?
Oh, I don't know.
Is that right? Because that's someone else said that. I'm like, really?
They both have the same property. It's so much easier to factor in.
That's freaking cool.
I was teaching somebody how to do this, and they were like, the teachers told us we're not allowed to group them that way.
No, you can group them that way. No, everything you did was perfectly fine because, see, in my weird mind, oops, I didn't want to do that. I wanted to do this. In my weird mind, I would just sit there and just say, oh, what the heck with it, and just go like this and just group them out. Because I take out the x squared, and I have 3x plus 7. Take out the negative 4, and I have 3x plus 7. It does the same thing, but this is a nice little trick to flip them around because you're recognizing patterns. You guys are picking up on the shortcut. That's awesome. It's easier to do.
Like, everything's so crazy. Like that, yeah, it's just easier. If you recognize that we have the same thing.
My little children are growing up. You're independently thinking.
It's so much easier that way.
Nice to get over taking over the world.
Do those, please. Okay. This is still section 6.4.
Oh yeah, we're supposed to be on the same page, right?
Yeah, just continue it on. All right, it's on the same, it's in the same pages and all that. I'll put it up here in a second because you got a couple minutes to probably get a few of them done.
A couple of days.
Humans.
Not due tomorrow.
What do you think, Knucklehead?
I just thank God